Right, so we're looking at the compulsory practical methods, how to answer these questions. We know the common questions, we know they're going to come up, you're going to get some of them, and we know at least for physics they're very, very similar in how we answer them. So we want to start off with thinking about what the investigation is, and always the first thing we're thinking about is what is our equation. So our first key point is always going to be our equation. Okay, so this is exactly the same for lots of different questions. So in paper 2 it's been things like the speed of waves, the acceleration of the carts on the air track or the little trolleys. Paper 1, we know it's been the density practical, the specific heat capacity practical, and there's another one as well, the resistance of a wire. So lots of different practicals, all basing what you're going to say around the equation. Right, so the equation in this case, it's asking us to find the speed of a sound wave. Okay, so there's two possible equations we could use to do that. We could use the wave speed equation, or we could use the speed distance time equation. Now in this case I'm going to use the wave speed equation. Sorry, I'm not going to use wave speed equation. You're going to use wave speed equation for the second question, but I'm going to be using for this one the speed is distance divided by time equation. Okay, so speed is distance divided by time. And that, as we know, is then going to inform our next two key points. So we're going to do distance and time. And that's telling us we need to know how am I going to measure the distance, how am I going to measure the time. Right. On top of that, it also asks to ensure how we're going to ensure they are as accurate as possible. So making results accurate, we need to understand what accurate means. So accurate means close to true value. Okay, so as close as possible to the true value of the speed of sound. So that's going to be what we're going to put in the bottom. Okay, so to put accurate, just lifting that straight from the question, it's telling us to do something, we need to make sure we do it. Right, so how are we going to do these things? So we're going to measure the distance, okay? How are we going to measure the distance? This is what we need to put in this information column. So we're going to measure the distance, we're going to use a trundle wheel, okay? Okay, so measure the distance using a trundle wheel. And this can link in with the accuracy, so you don't have, when we say you've got to include the accuracy, you don't have to include it at the end. You don't have to then do a separate paragraph at the end, but it might help to just do that. Okay, just get this all out of the way, then do this. So, but when I'm planning it, I might be thinking, right, I'm going to measure using a trundle wheel. Right, the further I make it, the better reaction time is going to be. So, as far as possible. Okay, so I'm going to go as far down a field or somewhere as possible, and I'm just going to put in brackets reaction time. So I'm going to improve reaction time, because if you've got, if the total time it takes for sound to get to you is 1 second and your reaction time is half a second, then you've got half a second out of the way where you could be getting that wrong, and that's a big proportion of the total time. If we double the time it takes for the sound to get to you to 2 seconds, then you're halving the error basically, because you've still got the same reaction time, but it's less of a proportion of the total time that you've got. Right, so on to the time. How we're going to measure it, we're going to start a stopwatch, so with a stopwatch obviously. Okay, so again we are mentioning what equipment we're going to use. So we're going to start it when we see something. So I don't know, might be an explosion, might be clapping hands, Okay, it's not giving us any details in here, so we can pick whatever we want for that, and we're going to stop when we hear it. Okay, so we're going to start it when we see something happen, stop it when we hear it, and that should give us the time it takes for the sound to reach us. And again, looking at the accuracy with that, if you do it once, you've got a big chance of there being a random error there. But if you do that lots of times, and take an average, okay, a mean average, that's going to make it more accurate, because you're going to reduce the effect of random errors. Okay, that'd be good, something good to put in your answer. So we can do it lots of times, take an average to reduce the effect of random errors. So what I want you to do now, using this plan that I've done with you, you need to use this to answer the question in full. Once you've done that, so start off wherever you want to. I would start off with, straight away, we would, to find the speed of a sound wave, we would measure the distance using a trundle wheel. That would be your first sentence. Once you've done that, looking at the second part of this, where I want you to apply that to a different question, I've given you the equation I want you to use. Okay, so speed of a wave in a ripple tank. So this is where we had the ripple tank set up, and we had lots of waves going across there. So it's difficult to measure distance and time, because the time is very difficult to measure. But how are we going to measure the wave speed? Using the frequency and the wavelengths. You've got to think about what those two things are. How are you going to make that accurate? Because you can't just follow, you know, if you've got a wave going across there, you're trying to follow this wave with your ruler, it's going to be really difficult to do. So how are you going to make that accurate when you're measuring the wavelength? How are you going to make it accurate when you're finding the frequency? Okay, because it's how many times per second is it sensible to count? How many waves in 1 second? Are you going to be able to count more than one of something in 1 second accurately? Okay, how are you going to improve on that? How are you going to make that better? So once you've done that, quick plan, probably quicker than the plan I've done. The plan I did was a bit more extensive than you need to do. Again, answering that in full.